All right, friends, I'm back for this part B of the part 2 notes. Okay, so we're still talking about solving or evaluating limits analytically or algebraically, same thing. You know, we're evaluating these limits without graphing or without looking at a table, although we could graph or look at a table to confirm our answers for these graphs. Just a little more heavy duty by having to go through and work on these manipulations. So I have two problems left for you, and they have square roots in them. So this is the third typical way of manipulating. So factoring is one way to manipulate your function. Trig functions, you have to know the trig identities to manipulate your function. And last but not least is multiplying by a conjugate. All right, so problem 8, continuing on from where we left off. The limit as x approaches 4 of the square root of x minus 2, all divided by x minus 4, okay? You know, and the same story holds true for all of these. In every single problem, you want to substitute directly to evaluate. So I'm going to substitute 4 in for x. Because I'm substituting, I can drop that limit notation. I'm going to substitute the 4 in for x in the denominator. And when I evaluate this, again, I get 0 divided by 0, which is indeterminate. I can't determine what that limit is, however, it likely exists. So I have to do some manipulation. All right, that means I'm starting over. I'm rewriting that limit notation, limit as x approaches 4, and I'm going to rewrite my function square root of x minus 2 divided by x minus 4. Okay, well, I can't factor. There's nothing to factor here. There's no trig, so I'm not thinking about trig identities. So my option is to multiply by the conjugate. I'm going to write that off to the side. Multiply by the conjugate. Now, it's been a very long time since I've taught Algebra 2 trig. But I do remember in Algebra 2 trig, we talked about a conjugate back when I taught it years ago. And I do know in pre-calc that there was discussion of a conjugate. It's also been a few years since I've taught that course. But this should not be the first time you've heard of a conjugate. So what a conjugate is it is the same exact expression, the same binomial, with an opposite middle term. And I want to focus on the conjugate of any expression with a square root. And hopefully you'll recall here in a minute why we would choose the numerator expression, the square root expression, to use as the conjugate. So I'm going to multiply this whole fraction. In the numerator, I'm going to multiply by the conjugate, which is square root of x plus 2. This is the conjugate of square root of x minus 2. Notice that it's the same binomial. I just have an opposite middle term. Now, I can't just multiply by anything I want, okay? I would change the entire function if I did that. In order to keep the integrity of the function, I have to multiply by a form of 1. Right? Anything times 1 is still itself. 10 times 1 is 10. 100 times 100 is 100. I'm just going to make my form of 1 look really fancy by rewriting that same conjugate expression in the denominator. Right? I mean, square root of x plus 2 divided by itself is 1. And so what I'm really doing is, this right here, I'm taking my original function and I'm multiplying. I'm going to put in quotes. I'm multiplying by 1 because I am multiplying by 1. An expression divided by itself is 1. It just looks like a really odd form of 1. Hassler, why would you do this? Well, because I'm a little crazy and because it works. So the reason why we multiply a square root expression by a conjugate is because when we go through and distribute, I'm going to put some parentheses here, I'm going to multiply square root of x times square root of x. Well, guess what? Square root of x times square root of x is the same as saying, I'll write off to the side here, square root of x squared. And those are inverse operations, the square root and the square. So I'm just left with x. And square root of x times 2 is 2 square root of x. And then I have to distribute that negative 2. So I get a minus 2 square root of x. Negative times 2 times 2 is minus 4. I have not substituted yet, so I need to make sure I go back and apply this limit. And so the reason why I would multiply a square root expression by its conjugate is because 1, my root goes away. 2, the middle terms disappear because they are opposite signs. That's why the conjugate has an opposite sign. And I'm going to be left with a much simpler expression of x minus 4. All right, another strategy of mine, I know so many strategies. Another strategy of mine is to not distribute this denominator. Okay, look, both of these expressions, the x minus 4 and the square root of x plus 2, they do not both contain square roots. So the magic that happened in the top is not going to occur in the bottom. Okay, in fact, because of that reason, because these do not both have square roots, it's not worth my time distributing that out. It was worth my time in the top because the square roots undid each other. I don't have square roots for both expressions in the bottom, not worth my time. And look, here's the reason why. When I go to rewrite this expression, have not applied my limit yet, so I need to write the limit. I'm left with x minus 4 in the numerator. Oh, look! One of my factors in the denominator is x minus 4. Huh, that's cool. Because look, the x minus 4 in the numerator divides with the x minus 4 in the denominator. Still not substituting. Got to write that limit. I'm left with 1 divided by square root of x plus 2. And that looks a lot less complicated than what I gave you. And now I can't simplify any further, so I'm going to go ahead and try my substitution again. Square root of 4 is 2 plus 2 is 4. Okay. So factoring to manipulate, trig identities to manipulate, multiplying by the conjugate to manipulate. All right, I have one more problem for you. It's number 9. The limit as h, I know because they like to throw h's and a's into things, so I thought I would too. The limit as h approaches 5 of h minus 5 divided by the big square root of h plus 4, but outside of that square root, still in the denominator, is minus 3. Well, I'm not factoring and there's no trig, but I have a square root. So I'm going to multiply by the conjugate of the square root expression. My square root expression this time is in the denominator. Now listen, the conjugate is the exact same expression, but the symbol between the two terms is the opposite. So I'm not changing the symbol under the square root. I'm changing the symbol between the square root term and the 3. Okay? And because I can't change the integrity, I have to maintain the integrity of the function, I'm going to multiply by 1 by writing that same conjugate in the numerator. Okay, so remember what I said. Oh yeah, by the way, I should have substituted into start. That's my bad. If I substitute into start, I just got so excited. I get 5 minus 5, which is 0. And in the denominator, I get 3 minus 3, which is 0. Oh yeah, okay, so I should be manipulating. I just got so excited, sorry. All right, so I'm going to go ahead and deal with this numerator times my conjugate and the denominator times my conjugate. Look, just write an equal sign. There we go. I'm not applying my limit yet, so I have to write the limit as h approaches 5. In the numerator, both expressions do not contain a square root. So I'm not going to waste my time multiplying these two binomials together because no magic is going to happen between the two expressions since that first expression does not contain a square root. However, in the denominator, the two conjugates, okay, magic will happen. So when I distribute, square root of h plus 4 times itself is just h plus 4. Square root of h plus 4 times 3 should cancel with square root of h plus 4 times negative 3. Just like in the other problem, those two middle terms canceled. Negative 3 times 3 is a negative 9. Okay. Oh, hey, if I clean this up in the bottom, this h plus 4 minus 9, that's interesting. H plus 4 minus 9 is h minus 5. And why is that interesting? Hopefully you're talking to the screen and saying, Hassler, it's interesting because I have the same expression, excuse me, in the numerator and denominator, so I can divide them out. You would be correct. All right, I'm not applying the limit yet. So the limit as h approaches 5, because I have a multiple terms, I'm going to use parentheses because the limit is being applied to all terms. So I'm going to group these together. Okay, I'm left with the square root of h plus 4 plus 3. And now I can substitute that 5 in. I get square root of 5 plus 4 plus 3, which is going to equal 6. Moral of this story, you're going to have to manipulate your expression or your function if you substitute in and you get an indeterminate answer. One way to manipulate is to factor. You could use trig identities, or you could multiply by the conjugate. All right, so you have book work to do, and you need to complete that book work and turn it in to me on Google Classroom.